Welcome back. In this lecture, we'll be looking at the next two OOP principles. So far we have been looking at the concept of objects and classes, and then we discuss the encapsulation and inheritance principles. So in this week, we will be looking at the other two principles, abstraction and polymorphism. So at the end of this lecture, you should be able to apply these two OOP principles in object-oriented program development. So first we'll start with abstraction. So abstraction means the difference between what and how. So if we start with the example of a TV. So we know what the TV can do, right? So we can see pictures, we can increase and decrease the volume. But do we know how the TV works? Unless you are someone who builds or repairs TVs, you don't know how the TV works, right? So that means we know what the TV can do, but not how the TV does that. So this same real-world concept has been applied in object-oriented programming, and we call it abstraction. So if we apply this concept to objects, abstraction means we know, or the other classes know what an object can do, but not how the object does it. So that means the other classes can use this object and its method without worrying about the features and other properties or functions that are internal to the object. So this is different from encapsulation, because in encapsulation, what we are doing is we have the data members of the object. We are hiding those data members and expose them through the public method interface. In this case, we are mainly talking about the functionality of the object. That means what the methods can do. So the internals of the methods are not exposed to the outside world, but what the outside world, that means the other classes or the other objects can know, is how the methods can be used. So this inherently helps us to manage complexity, because we can change the internal logic of a method without worrying about affecting other places that use this method. So as long as the method signature remains the same, we can easily change the internals. So because of that, we can easily change our code along the time, and we can easily reuse our code, as you will see later. So to achieve abstraction in Java, we have interfaces and abstract classes. So in the previous lecture, we looked at interfaces. So today we'll start with the abstract classes. So what is an abstract class? It is just like an ordinary class, that the difference is it cannot be instantiated. In other words, it means that no object can be created from this abstract class. So to create abstract class, we add the keyword abstract. So we can say public abstract class name. Or if we take another example, public abstract class employee. So if we can't create objects, what's the purpose of having such a class? So let's find out. So in certain cases, the parent class or the superclass has functionality that is common for all the child classes, but the parent class is too abstract, or it does not have all the information to be used via creating an object. So if you take an example, let's say vehicles, so we have to create vehicle objects, but if you take a vehicle, it could be a car or it could be a motorbike. So when we are creating objects, what we will be creating is car objects or motorbike objects, but not vehicle objects itself. So that is what we mean by the parent class be too abstract to be used in object creation. So think of a method of this vehicle class, we can say move method. So every vehicle can move. So however, how the car moves is different from how the bicycle moves. So that logic is specific to the subclass. So inside the move method in the car, we will be adding the logic to move the car, and similarly inside the motorbike, we will be writing the code to move the motorbike. However, in the parent class, we can specify that the vehicle can move. So what the abstract class, or this in this case the parent class, what it specifies is vehicle has a method move. So that is the what part. So the vehicle class says what a vehicle can do. What the vehicle can do, it can move. But how can the vehicle move? The abstract vehicle class cannot determine that because it is specific to the subclass. So it is too abstract. So it just says vehicle can move, but how the movement happens is determined by the subclass implementation. So it should be clear to you by now why we should not be able to create objects from an abstract class. Now, if you think of this same example. Now, suppose we allow the creation of a vehicle object, but now someone wants to call the move method. But has the move method been implemented in the vehicle class? No. Why? Because the vehicle does not know how to move. It is specific to the subclasses. So if you create an object and if someone calls the move method, you are in trouble. Why? Because their move method is not implemented in the vehicle class. So in that sense, we should not allow vehicle class objects to be created. So in order to achieve that, we can make the vehicle class an abstract class. So the related concept is abstract method. So that's what I just discussed in the previous slide, the move method. So move method that is included in the vehicle class is an abstract method. So that means we in the vehicle class, we will be only adding the method signature to show that vehicle has a functionality called move. So implementation is not given. So what you have to realize is if there is an abstract method in a particular class, that class must be declared as an abstract class. Why? Because if we allow to create objects, there is no way to execute this abstract method because it is not implemented. On the other hand, a class can be an abstract class even if it does not have abstract method. So that is a case where in the vehicle also, even if you have a dummy implementation for the move method, we should not allow the creation of vehicle objects because it is not meaningful. Because if you are creating car objects and motorbicycle objects, that means you are creating all the objects you need. So if you, on top of that, if you create vehicle objects, it's no use. So because of that, even when there is no abstract method in a particular class, we can, if we want, declare that method as abstract so that no other class can create objects from this class. So if a child class extends an abstract class that contains abstract methods, this child class must implement all these methods. Otherwise, the child class should also be declared as abstract. So this is similar to the case of implementing interfaces. So you will remember that I told if a class implements an interface, all the methods in that interface must be implemented by the corresponding class. So all the method in the sense, the abstract methods that are there in the interface. So similarly, in an abstract class, if a child class extends this abstract class, and if this abstract class has abstract methods, then the child class must implement the abstract method or declare again itself as an abstract class. So let's look at another example. Now here's a code for the employee class. So as you can see, it is an abstract class. We cannot create employee objects from this class. If you try to create an object, you will get an error. And as you can see, this class does not have any abstract method. And if you want, now if you talk about employees in an organization, we have different types of employees. academic employees, non-academic employees in the context of a university, for example. So in that case, how to compute their salary may depend on the employee type. So in that sense, there can be a situation where we don't know how to add the general logic at the employee class level. In that sense, we can use the abstract method. So instead of writing an implemented method for the compute pay, now we are declaring it as an abstract method. That means we are just adding the method signature with the abstract keyword. Remember, for the interfaces, we don't have to add the abstract keyword because by default, when you are writing a method signature, it is considered as abstract, but in the abstract class, you have to specifically say it is an abstract method. So now, a subclass, the non-academic employee. So if we have this scenario, that means our abstract class does not have any abstract method, our non-academic employee does not have to worry about implementing any method of the superclass. However, if our non-academic employee is extended from this version where there is an abstract method, then the non-academic employee class must extend this, must implement this compute pay method. Otherwise, you will get an error. Or the non-academic employee class should also be abstract. But if you want to create objects from the non-academic class, you cannot make this abstract. And if you are not going to make this abstract, and if employee has an abstract method, then you must implement that abstract method here. So here's an example from our previous lecture where we had to get functionality for the warriors and monsters who can fight. So what we did was we added a new interface called iFighter, which had an abstract method called fight. So in Java, there is this concept of marker interfaces. Marker interfaces means interfaces that don't have any abstract methods added. So they are like empty interfaces. So why do we need that? Even if an interface does not have any method, it can be used to impose some restrictions on the objects when in execution. For example, serializable. So when we are writing objects to our hard drive, we say we are serializing that object into the permanent storage. So not all objects can be serialized by default. If you want to serialize a particular object, the corresponding class should implement the serializable interface. So this serializable interface does not have any methods, but it adds this restriction that only the classes that have this serializable interface implemented can have their objects serialized. So there are some other interfaces like that. For example, clonable. You can have a look at the Java API and see how these marker interfaces are being used. So now we learned that we have two ways to achieve abstraction: interfaces and abstract classes. How much abstraction do we get from the interfaces and abstract classes? So if you take an abstract class, we can say it provides 0 to 100% abstraction. That means at times there can be an abstract class without any abstract method. That means all the methods are implemented. So we say it is zero abstraction because every method has been explained. So no, just method declaration. On the other hand, at the other extreme, an abstract method may have only method signatures. So in that case, we say abstract class achieves 100% abstraction. So there can be scenarios in between because an abstract class can have some methods implemented and some methods just declared. And interfaces before Java 8 used to be 100% abstract. That means it only contained abstract methods, no implemented method. But after Java 8, now we have interfaces where we can define static and default methods. So both these types of methods are just methods with code, or we say implemented methods. The only difference is in static methods, they cannot be overridden by the classes that implement the interface. In contrast, the default methods can be overridden by the implementing classes. So this has been introduced because of a very tight, rigid restriction the interfaces introduced. Now suppose an interface in the Java API, the developers want to add a new method to the interface. So they add the new method to the interface and release the next Java version. What would happen? There could be millions of classes in millions of programs written worldwide that have used this interface. Now in the next version, all these classes will be throwing errors. Why? Because now the interface has an abstract method that these classes have not implemented. So this is a very tight restriction. So you can't change an interface after defining it. Of course, if you are writing your own code, you can always go and add methods to the interfaces. But when the code is used by thousands of people worldwide, you can't simply add new methods to the existing interfaces. To avoid this problem, they introduced the static and default methods. Then now even for the existing interfaces, we can add these new methods as implemented methods. So even if you don't know how to implement, we can just add some dummy code and add that method to the interface. However, we cannot replace interfaces, abstract classes by interfaces, because still interfaces cannot have constructors. So a related concept to abstraction is the abstract data type. In other words, abstract data types such as queue or hash map, they extensively make use of this fundamental concept of abstraction. For example, if you take a queue, we know it has specific characteristics. That is, it is first in, first out, FIFO. And then it supports a set of operations: insert, remove, examine. But how to insert an element and how to remove an element and how to examine the queue depends on the actual implementation of the queue. So this is the idea of abstract data type. The queue interface defines what operations can be executed on a queue. So these are insert, remove, and examine. But how these methods are implemented is not given in the interface. That is being designed by the subclasses. So if you look at the Java API related to the queue, you will understand this. So if you visit the Java API for the queue interface, you will see that it has set of abstract methods and it has a set of classes that implement this queue interface. One such method, the class that is commonly used is the linked list. Now see what we have done here. We are creating an object of the type, we are creating a variable of the object type queue, and to that we assign a linked list object. This is possible because linked list is a class that implements the queue interface. So this queue interface, now see our variable is of the type queue. Now queue.add will work because even in the queue interface, it defines the add method. That means it has the method signature for the add, although the implementation is not there. When this is being called, the actual object that is of type linked list, it will be called, and the implementation of that linked list object will be called. So the concept that we just discussed is also related to the concept of polymorphism. Now if you look here, I told you that queue is an interface and the linked list class implements this interface. Now here our variable is of the type interface and our object that is assigned to this variable is of the type linked list. So how is this possible? This is possible because of the concept of polymorphism. Polymorphism means the ability of an object to take on many forms. So what do we mean by many forms? So in this example, a parent class reference has been used to refer to a child class object. So when I say a parent class, this can be an interface also. That is exactly what we have done here. Here, the parent class reference, that means the Q reference, has been used to refer to an object of the class that implements this Q interface. This class name is linked list. So this is polymorphism. So this is achieved because of the inheritance that exists between subclasses and superclasses, as well as interfaces and classes. So to understand the concept of polymorphism, let's look at this visual example. So we say an object can pass more than one ESA test. If it can pass more than one ESA test, then that object is polymorphic. That means, for example, if you look here, now we have an employee class. So as I told you earlier in a previous lecture, every class, even though we don't specifically specify, every class extends from the superclass object. That is a superclass for all the objects. Now, all the classes. So now think of the second picture. Now we have the employee class that extends the person class, which we have specifically defined by saying public class employee extends person, and implicitly we get that person is extending the object superclass. Now suppose we create an employee object. In the left hand side, let's say employee Peter equals new employee. Because since we create the Peter employee using our employee class, we say Peter is an employee. And since employee class is a subclass of the object class, we can also say Peter is an object. So now if you take this Peter object, it passes more than one ESA test. So what are these ESA tests? Peter is an employee, Peter is an object. So it has two ESA relationships. So because of that, now we say this Peter object is polymorphic. It can behave as different objects. So in one case, it can behave as an employee. In the other case, it can behave as an object. Object, this means that an object we create from the object class. Now look at the other example. Now here when we say employee Peter equals new employee, we can say Peter is an employee. And since person is a superclass employee, we can say Peter is a person. And finally, we can say Peter is an object. Now, how many ESA tests does this Peter object pass? It passes 3 ESA tests: object, person, employee. So this object is also polymorphic. So next question, are all Java objects polymorphic? What do you think? Yes or no? The answer is no. So if you write your own code, all the classes you write, if you create objects from that, they are polymorphic. However, there is one class, if you create object from that class, that object will not be polymorphic. This class is none other than the object class, as you see here. Because object is the very super class, it does not have any parent. So if you create an object from this object class, it is having only one ESA relationship. Let's say object X equals new object, then this X is an object, nothing other than that. So it has only one ESA test. So other than objects created from our object superclass, all the other objects you create are polymorphic because they have at least 2 ESA relationships. One with the class that you have written and one with the implicit relationship you get from the object. So let's see how this ESA relationship can be further understood. So now we have public interface vegetarian and we have public class animal, and now we have an interface public class deer extends animal implements vegetarian. So if you create a deer object, let's say deer D equals new deer, then this D is a deer, this D is an animal, and this D is a vegetarian, and this D is an object. So it has 4 ESA relationships. Again, remember, not only for the superclasses, when the class implements an interface, we consider it as another ESA relationship. Now, see how we can assign. So what we said was a reference, a variable of the superclass type can be assigned to an object of the subclass. So that is what we are doing in line 2. In the first line, dir d equals new dir is the usual way of creating objects and assigning them to variables. But if you look at the second one, animal A equals D, that means we can, in another word, we can say animal A equals new deer. So what does that mean? A variable of superclass, that means in this case, a variable of type animal now has been assigned to an object of the subclass. What is this subclass? Deer. So same, so vegetarian B equals D, that means a variable of the interface vegetarian has been assigned an object of a class that implements this vegetarian interface. So if you look at the last two questions, dir d equals new animal, animal A equals new deer, which is correct, which is wrong. So as I already explained, animal A equals new deer will work. Why? So we know a subclass means it has all the functionalities of a superclass plus some other additional functionality. So when we say animal A, we are expecting an object that has all the animal functionalities. So in that sense, for that we can give a deer. Why? Because a deer object has all the functionality, all the properties of an animal. How about the other one? Dir d equals new animal. Now, deer has more information or more properties, more methods than an animal because it extends the animal class. So this reference is expecting an object with all the deer functionality. To that, if you give an animal, what would happen? The reference does not get all the information that it expects. So in that case, this assignment will fail. In other words, if you just write dir d equals new animal, that will be wrong. So why polymorphism? It is very, very useful in many cases. Now think of our example we had in the previous lecture. The warriors, super warriors can fight and the monsters can fight. Now we want to have an array of objects that can fight. How can we do that? We want to pack the game inhabitants who can fight into a single array. We can't have two arrays. So if we can have two arrays, then the answer is easy. One array will keep the super warriors, other will keep the monsters. But if you want to have a single array, how can we do that? So polymorphism comes into play here. So what we can do is we can define an array that can contain I-fighter objects. So when we say I-fighter objects, it can be a warrior object, super warrior object, or a monster object. So that is what we mean by the second point, to mix different related types in the same collection. So what is the first one? Invoke abstract operation. So think of our employee example. Now employee had the compute pay method, which is abstract. So and then we have a non-academic employee class that implements this method because it extends the employee superclass. Now we can have a statement which says employee E equals new non-academic employee. So now this E is having the reference of employee. Now if you type E.compute pay, it will refer to the employees. It will first refer to the employees abstract method. That means then because the related object is a non-academic employee, then from there it will call the actual implementation. So if you are using a superclass reference to a subclass object, it helps us to invoke abstract operations. And think of a method, right? So this method takes both, let's say, academic employees, non-academic employees, and does something based on the type of the employee. So if we get an academic employee, it will take one decision. If we get an academic employee, it will take another decision. But we have to do this in the same method. How can we do that? Can we say we can define two parameters? So if you do that, always, since we are getting only a single object, always, so if you have a method that takes one parameter as academic employee and the other parameter as non-academic employee, whenever we get the method, always the other parameter will be null, which is not a good design. So instead of having two such parameters, we can have a single parameter of type employee. So when we write the method, we say this method will take a parameter of type employee. But when we actually pass the parameter values when the method is executed, we can either pass a non-academic employee object or an academic employee object. So that is what we mean by the third point. Pass more specific object to a method that expects a parameter of a more generic type. So here the generic type means the employee, because it's a superclass, it's more general, and the specific means the subclass, non-academic or academic. So similarly, if a method is going to return an object depending on its method logic, sometimes we don't know whether it will be an academic employee or a non-academic employee that will be returned. So in that case, our return type can be employee. So when the return type is employee, the method can return both academic employees and non-academic employees. So the last one we already used to declare a more generic field, which will be initialized and specialized later. So here our more generic field is A, which is corresponding to the general, more general method class animal, and this A later, depending on the rest of the logic, can be assigned to a D object, or it could be that the last one should be a simple A, not capital A. So maybe A should be assigned based on the output of a method. So we don't know what this method is returning us. So get animal would give us a deer or a tiger. But when we say animal A, and when we say A equals get animal, it can accept a tiger or it can accept a dog or whatever animal. So this phenomena has been used in our previous example as well. If you look here, see, now a variable or reference of the generic type Q is now being assigned to an object of the more specific type linked list object. So, and this is the place where you say this execution of abstract operations. So for the Q class, we have the abstract method. So when that is why we can call Q.add, because this Q has the abstract method definition add, and when it is being executed, now it realizes, okay, now this Q refers to actually a linked list object. So it will go and execute the linked list, the method in the linked list. However, we can write this piece of code as Q.add because the Q interface has the abstract declaration of the method add. So a related concept is dynamic binding. So now if we look at this employee example, right? So now let's think of this scenario. Now we have an abstract class employee which has the compute pay method implemented. And from this we have the non-academic employee extending, and it also has a compute pay method. Now suppose we create an object like this, employee E equals new non-academic employee. Which method will be executed? Compute pay or in the non-academic class or the compute pay in the employee class. This is determined through this process called dynamic binding. So the rules are, if the superclass and the subclass have the same method implemented, when we say, for example, employee E equals new employee, and then when you call E dot get, E dot compute pay, if both employee and non-academic employee have the compute pay implemented, we give priority to the implementation in the subclass because it has more information than the superclass, right? Is it clear? So if a method is implemented in both subclass and superclass, and if you are using object reference to the superclass, for example, as employee E equals new employee, new non-academic employee, and when we call E dot compute pay, always a non-academic method will be executed. And the other scenario, abstract class has the compute pay method as an abstract method, and the non-academic class has the implementation of the compute pay. So then this is straightforward. We have to, the runtime environment will dynamically use the implemented method in the non-academic class. And the other one, the compute pay method is not available in the abstract employee class at all. Then again, the answer is straightforward. The method compute pay in the non-academic class will be used. So that the only confusing place for you would be if the same method is implemented in the subclass and the superclass. So when the object reference is to the superclass, still the subclass method will be implemented. The final scenario is for example, the compute pay method is defined in the employee class, but not in the non-academic class. Again, should be straightforward. If we call E dot compute pay, there's only one place where it is implemented, that is in the superclass. So the superclass logic will be executed. Another concept is casting. So casting is of two types, upcasting and downcasting. So because of the polymorphic behavior of objects, now we know the same object can take different forms. How we can change between these different forms is defined by casting. So if we have an object that is currently in the form of a subclass, and if you want to convert into an object of a superclass, which we call the upcasting, then we can directly do it. For example, so we saw this example earlier also, object O equals new monster. O is the object is the superclass, monster is the subclass. So we can directly convert the monster the subclass object into the object of the type superclass object. Another example, the Q equals new linked list. So the linked list object, which is of the type subclass, can be directly converted to an object of the type superclass type Q. And another example, employee E equals new non-academic employee. So the object that is of subclass type can be directly converted to an object of the superclass type. However, the other side is not true. That means converting an object to a subclass. That means we have an object that has been defined in the context of the superclass. Now we want to convert that into a subclass object. For example, we want to say monster A equals new object, right? So that cannot be directly executed. Why? As I told you earlier, the deer example. So if I try to say deer D equals new animal, it is a problem. Why? Because deer is expecting the full functionalities of a deer, but the animal has only part of it. So we can't do such an assignment directly. So if you want to do it, we'll have to have this specific reference. So for example, here when I'm downcasting an object of type O into a object of type monster, I have to specifically say I'm converting this into a monster by putting the class name within brackets. So, but not all the classes can be converted to the type of a subclass. Some casting will not work. So, because you know now sometimes we can convert do an upcasting, and later we'll have to do downcasting. So although we do the upcasting implicitly without specifying anything specific, now the same object cannot be again downcasted implicitly. We have to specifically add this condition, but if we make a mistake, it will give an error. So we have to, before doing this downcasting, we have to make sure that the cast is going to be successful. So in order to do that, we can check the actual type of this object. So if, for example, in the previous case, although we are assigning this new monster object to a type O, the actual object is a monster object. Now, when we say object O, in the context of this O reference, this object, monster object is acting as an object, but the actual object is of type monster. So every object has an actual type, but depending on its reference, it can act as a superclass type. So because of that, before using an object to be downcasted, first check what is the actual type of that object. You can do that by checking the object type. And if you do a wrong casting, we will get an exception which we call the class cast exception. So in summary, we discussed the last two object-oriented programming principles, abstraction and polymorphism. And abstraction, as we learned, can be achieved through abstract classes and interfaces. So this completes the 4 fundamental concepts in object-oriented programming. In next week, next lecture, we will look at the some other important object-oriented concepts, specifically the concept of cohesion and coupling. Thank you.